Welcome back to the 12th Annual Life Sciences and Society Program Symposium. I know many of you have been here this morning, yesterday, the day before, last weekend, but a few of you are new. I'm Mary Schenk. I'm the director of the symposium, the program that runs the symposium. I am also co-chair. Thanks. Okay. Which apparently some of you like, right? We're also co-host with some faculty on campus the Saturday Morning Science program, and we just had one of the Saturday Morning Science events this morning. We had Richard Alley, a symposium speaker, coming last week as part of that as well. So if you're interested in these kinds of events, we can put some flyers outside. You guys can come. This kind of thing continues here almost every Saturday morning during the fall and spring semesters here at Mizzou. So you can come. It's on different topics every week, a lot of Mizzou faculty, local faculty, and then sometimes we bring people in from the outside as well. So today, this afternoon, we're going to continue with our focus on some of the consequences of climate change that people frequently don't think about as much. So we're going to hear first about climate change and health, and then we're going to talk later this afternoon with Naomi Oresky's talk at 3:30 about what people are starting to do in local communities about climate change. But to introduce today's speaker, I'm going to have Mark McIntosh, who's Vice Chancellor for Research, Interim Vice Chancellor for Research, incidentally one of the main funders of this event.
Thank you, Mary, and welcome back this afternoon. I want to really recognize Mary and Jack and the entire staff of the Bonn Life Sciences Center for putting on a terrific conference. This event continues to grow each and every year that we have the Life Sciences and Society Symposium. A special recognition to the committee, the advisory committee that helps work with Mary and Jack to put together these events every year on timely topics that are of importance to us as a society, and most importantly, that bring together people of totally different backgrounds who are all interested, of course, in really examining some of the challenges that face us as a society, and at the interface of where science and the community comes together. We as scientists, as you've heard multiple times during these talks, sometimes have a difficult time communicating the latest research findings to the community as a whole, and it's through continuing efforts of the people that you're hearing in events like this that we get a better handle and a better ability to communicate with the community. My task today is to introduce our next speaker, Dr. George Luber. George works for the CDC. I want to read his title so that I make sure I get it right. He is the Chief of the Climate and Health Program within the Division of Environmental Hazards and Health Effects at the National Center for Environmental Health with the CDC. So it's about a 4-line title. It's very impressive. So George is an epidemiologist by trade. He finished his PhD at the University of Georgia, and Georgia seems to be a theme today as well, from what I've seen so far. So Georgia seems to be at the forefront of training environmentalists and anthropologists and so on to look at climate change. George got his PhD there in 2002 and immediately went to work for the CDC. He went to work as an epidemic intelligence service officer and staff epidemiologist, and he worked at CDC in that capacity for a period of time. He has a long list of accomplishments, and that's before he moved in to being the chief of the Climate and Health Program Division. So he has a long list of accomplishments while he's been at CDC. And so let me just highlight a few of them. He is the co-chair of the Climate Change and Human Health Interagency Work Group at the U.S. Global Change Research Program. He is a member of the American Anthropological Association's Presidential Task Force on Climate Change. He has been a leader in 2 major national climate assessments, the U.S. National Climate Assessment and the Intergovernmental Panel on Climate Change. fifth assessment report. So he's had a long history of public service in examining climate change, and as you'll see today, especially as it relates to human health. So his research interests really focus on health impacts of environmental change and biodiversity loss. Biodiversity has become a key focal point in lots of life sciences investigations to this point in time. As a microbiologist by training, we've actually become impressed over the last 5 to 10 years with the biodiversity of the microbial populations that live in us and on us and around us. And changes to that diversity have significant impacts and significant health impacts. So the way that we now present the concept of microbes and human pathogens and infectious diseases to medical students these days has more to do with the relationship between pathogens and non-pathogens, and the non-pathogens outnumber the pathogens by many-fold. The relationship between those microbes and the human organism has a significant impact on health. And George is going to actually talk a little bit about how human changes, environmental changes, and so on, have an impact in that biodiversity, which then subsequently, of course, impacts human health. His research lately has focused on the epidemiology and prevention of heat-related illness and death, especially in urban populations, and that's going to be the subject of what he's going to talk to us about today. So, George, it's a great pleasure to have you here. Welcome to Mizzou. We look forward to your talk.
Hear me now? Well, I'd like to say thank you to everybody for just allowing me to be here today. I would have come here even if I wasn't a speaker, just to hear Wes and Naomi. I'm dead serious. You guys are, and me included, treated to just a fantastic group of people to speak today. And Marcia last night. I want to thank Mary for inviting me and being so gracious a host. And thanks to you guys. I was an undergraduate at Florida, graduate at UGA, and so welcome to the SEC. You all are all right. I found that out late last night. So anyway, thanks for having this opportunity to speak today. I'm going to try to bring climate change into a different frame, and that is why you should care about it as a function of your health. And also talk about what we're doing about it at CDC, what we think is important, and hopefully give you a sense of the magnitude of this problem. Now, we've been talking about communication, and this image, has anybody seen this image before? Okay, I won't. No, you want to explain what it is? Okay. So, and this came to mind when I was talking to somebody in New Mexico when I was on vacation, and we were trying to find a place to camp, and all around us, the national forests were closing because there was fires ringing us everywhere we went, because it was 2012, and it was just fires everywhere. And we're talking about wildfires, and I started mentioning climate change by mistake, and this guy that I was talking to said, I think it's hubris that humans could think that they could alter the chemistry of the planet's atmosphere. It's too vast. We just are so full of ourselves. And this image came to mind, which I'd seen before. And the image on the left is a representation of all the water on the planet at sea level pressure contained in a single sphere. This is not just all the oceans, not just all the glaciers, the ice caps, not just all the water and all the vegetation on Earth, not just all the rivers, including the groundwater and all the water vapor in the air. Everything on the planet, that's how much water we have. That's very little. Now, look at the right, and that's the entire atmosphere, again, compressed into sea level pressure, contained into a sphere the size of the Earth. If you were to do a different representation, to describe the thickness of the atmosphere, all you'd have to do is take a basketball and wrap it in saran wrap. That's the thickness of the atmosphere, and that's what the astronauts described as they left the Earth's atmosphere for the first time, that thin blue line. And that really is all we've got. And it isn't hubris to think that we could alter the Earth's chemistry, atmospheric chemistry, because we already have. And Marshall showed this earlier. This is CO2 levels 800,000 years ago, taken through actually observed samples in air bubbles in ice cores. So this is direct observed evidence. And he said it co-varies with temperature, and there it is. It co-varies with temperature pretty well. And that's the physics we know from going back a couple hundred years. This is not rocket science. What we do know now is that we are, again, in a different era. Here's the abrupt change since the Industrial Revolution. We're at 400 parts per million. We crossed that about a year or two ago, and now we're consistently above this. And if we look into the future just a little bit, we got to shrink it down and look to where we'll be in 40 more years. And so that's pretty remarkable. And that's a big deviation from where we're at. So no, it isn't hubris that we can't change the composition of the Earth's atmosphere. We've done so already, and we'll continue to do so. Whether we can handle it is the big question. Well, actually, you know what this brings to mind? I forgot to say. It's not why are we experiencing global warming. Is it why haven't we experienced more? Why hasn't this shot up? We should see a lot more dramatic rise in temperature based upon this rise in CO2, right? Well, we are seeing it, but we're just not measuring in the right place, because most of 93% or so of all the temperature that's been maintained in the Earth system doesn't go into the land surface observations, it's going into the ocean. So we have to understand different ways of looking at the same problem. Here's ocean heat content, again, rising year after year since we first started systematically observing it. And correspondingly, we have independent lines of evidence that corroborate the fact that the ocean is holding more temperature because of sea level rise. Most of this sea level rise that we've observed since the late 1800s is not due to greater inputs of water into the ocean from land-based ice masses. It's due to the thermal expansion of the oceans. So this has occurred at a rate of about 1.8 millimeters a year. I tell this to my dad who lives on the coast of Florida. He's like, I can get out of that way pretty quickly. But if I show him this, it's actually accelerating. If we break it into discrete chunks, that becomes a little more problematic, and we have to start thinking about where we're positioning all our critical resources. So ocean accelerating sea level rise, again, occurring at the same time as we're seeing the late 80s, the acceleration in land surface temperatures. Other indications of a warming ocean include decreasing summer sea ice extent. This is the summer minimum. At the end of the summer, when it's the hottest, how much ice do we have left in the Arctic? And this is all sea-based ice, not fast to land, so it comes and it goes. And if we want to look at it graphically, this is 1984, and here we have 2012, and a lot of it's gone. There's good news, though. There's a lot of oil in here we now can get access to. That's not a bad thing. I'm kidding, but and 2014 and so is you know, the picture gets worse and worse and worse. So independent lines of evidence showing that the Earth's climate is indeed changing. It's not just warming, it's changing in a number of different ways. We have more water vapor in the atmosphere, we have less sea ice, we have decreased snow cover. This is important for many communities that depend on snowpack, and it's et cetera, all independent observations that corroborate the same system change. So, how do we know all this? Well, as Mark mentioned, we have assessment reports, and these are really important for policy. This is the IPCC 2015. I was a lead author on this chapter where we take all the evidence. It doesn't really create new evidence, but it says what's the quality and strength of the evidence in all different areas, and we synthesize it and we publish this massive report, and we do it also for the United States. It's actually mandated by law that we do this, and we have to convene every few years and assess the science and provide it to policymakers who can ignore it if they want. What we found is that we're seeing increasing strength of the evidence, really following the 2007 landmark IPCC report that stated that the changes in the Earth systems are unequivocal. We're seeing temperature rise in the United States, about 1.5 degrees since 1895, but most of this has happened since the 1980s. We are seeing changes in the frequency of extreme weather events. These include heat waves, which is one of my specialties, floods and droughts, too much water, too little water, as well as increases in the frequency of high magnitude or high category hurricanes. We have seen sea level rise, and we're going to see a lot more of it towards the end of the century. But we're seeing also other subtle changes that are relevant for ecology, like the lengthening of the frost-free season. The growing seasons are extending, and we're seeing shifts in biomes as a result of that. We're seeing changes in the nature of rainfall. Increasingly, rainfall is coming down in hard, heavy downbursts rather than gentle soaking rains, which are important for water management. And I mentioned Category 4 and 5 storms. But there's other parameters that are important as well. We're not just seeing changes in the mean temperature over time, which people think of as climate change. That is climate change. But we're seeing changes in the variability of weather patterns as well, which is the frequency of extreme events. We're also seeing that these impacts aren't being experienced evenly across the landscape. Some places are warming much faster than others, and we have to identify where those places are. So this is a map from the National Climate Assessment that showed that the average warming is about 1.5 degrees, but Minnesota's warming at over 3 degrees, Colorado as well, and if you find yourself in Alabama, there is no climate change. Dead serious. No climate change in Alabama. It's actually cooled a little bit. And that's largely due to other land cover changes, the reforestation of the South, et cetera, and the influence of large forests on that. Same as Georgia, almost no temperature change, but that's taking over a 100-year span. But I mentioned temperature, climate change versus climate variability, and I think this illustrates it quite well. So this is, I'm gonna go back one. This is average summertime temperatures, 1950 to 1980, a climate average of 30 years. And you see that you have a classic probability distribution. You have common events occurring most frequently, and rare events occurring less frequently. So as you shift this, as you go forward in time, you would expect this curve to shift to the right, right? It's getting warmer, so we're gonna make it warmer to the right. But something else happens. This is in 10-year increments. As we get warmer, the curve also gets flatter, which means normal isn't as normal anymore, that we're getting more observations on the tails of the distribution, meaning not just hot weather, but much more frequent hot weather. So that as the tails of the distribution increase, fatter tails mean bad news. We're going to get much more variability, and if imagine this curve being totally flat, and across, an extreme day would be just as common as a normal day. And that's one of the key things that we have to deal with, is the changing frequency, intensity, and magnitude of these types of events. This is just temperature, but we see it in rainfall as well. And sometimes these events can be well beyond anything we've ever experienced. So as Mark mentioned, I was an EIS officer. That's the disease detectives we get sent out on outbreaks. And one day during the Freedom Fries fracas with the French government and the White House over, I can't remember, where we weren't even allowed to mention the French government, they had this massive heat wave. And surprisingly, they called for help. It never happens. And so we got sent the next day, actually luckily the day the heat wave ended, because there's not much air conditioning in Paris, to help them with this heat wave. And what we discovered was that, and they have very good electronic death records, so we had pretty good sense of what the mortality was. And this is confirmed mortality. So this is how anomalous this event was. 2003 was well beyond anything they'd ever experienced in Western Europe. And this is the confirmed mortality from that single event. This is when the medical examiner identified the cause of death as high core body temperature or hyperthermia. It doesn't happen very often because the circumstances in which you need to get that evidence aren't always there. You find somebody dead a day later, they're cold. But they confirmed 30,000 dead. A better way, and this is what we helped them with over the next year of assessing the impact of this heat wave, was looking at the observed mortality for that period of time over the expected mortality, which is, if you expected 30,000 deaths, how many did you really get? Because not everybody dies of hyperthermia. They die of heart failure, renal failure, electrolyte imbalance, or whatever. Large variety of health outcomes from heat waves. So the excess mortality from this event was 70,000, not 30, from a single event in a place in the world that ought to be able to handle every single one of these deaths. And we believe that every single heat-related death is preventable, and that's what we're striving to achieve. But these types of events can really bring to mind the magnitude that these impacts can have in a situation where multiple systems fail. And in this case, it was August, folks were on vacation, physicians weren't recalled, too many elderly were given too little supervision in nursing homes, and adequate care wasn't available, and the knowledge base for what heat waves can do wasn't in place. So this brings us to what the key health threats from climate change. So I'm going to talk about the what of climate change and health, I mean what health conditions are impacted, but more importantly, how. And so there's three key health threats that I'm going to discuss. And the first is the disasters within a disaster, that the sheer magnitude of some of these extreme events that climate change will bring and have brought, as well as the increased frequency, so each event erodes our capacity to respond a little bit by little bit, increases the probability that we'll have these disasters within a disaster where multiple systems fail. When you lose communication and transportation and the ability to respond is eroded as a result of the sheer magnitude of the event. This we've seen multiple times in situations like Katrina and Sandy and whatnot where, oh, we put the generator in the basement. That was a bad idea. And that's the kind of things we're working to. How do we prevent those types of disasters within a disaster? One simple example of a loss of a key resource during these events is electricity. This is 2003. It's just a regular day. Temperature was a little high, but they lost power. And this is what happened to death rate during that power outage. Just losing power, this is what happens to mortality. So we know we can't lose power during these heat waves. Imagine an extended heat wave in Phoenix where power goes out because the hydro dams are too low because ice pack or snowpack is decreased, or the cooling ponds for the generators are too hot because it's been hot. So you have a heat wave in Phoenix where everybody's adapted to what? An air-conditioned environment. And so they try to leave. And what's around Phoenix? More of the same. And the pumps in the gas stations won't work because they run on electricity. So this is what we're trying to develop scenarios for, is how do these sheer magnitude of these events can result in this type of effect. And it's not just local or very small effect. They're distant and long-range transboundary effects of these impacts. This is where people went from Katrina, the diaspora. This is zip codes, a number of people who applied for aid after Katrina. You can see right in here a kind of a dark spot. We worked with the city of Austin, Texas on a hazard assessment early on when we were doing this work, trying to get a sense of how they would think about climate change and health. And we said, here's all the meteorologic hazards that you deal with, and here's kind of some of the health effects. Now you guys think about what your biggest problems are. They came back to us and they said, hurricanes. I said, what? When was the last time you ever had a hurricane in the middle of Texas? They said, never. However, every time a hurricane hits the Gulf of Mexico, we get a flood of people coming to our doorstep requiring food aid and housing and vaccines, and it crushes us. And we don't have the capacity to deal with hurricanes because of everybody showing up at our door. And this just illustrates how this all works in a system. And this isn't just working in the US, think of Syria and other parts of the world, how these effects work transboundary. So this brings us to the second key threat from climate change, and that is this cumulative stress that the most vulnerable portions of our population experience are going to be exacerbated. This is death, or morbidity and mortality is the way we say it at CDC, by 1,000 cuts. The impacts of climate change add to the cumulative stresses currently faced by vulnerable populations, and especially in those locations that experience the most impacts of climate change and these persistent threats. So this is lovely Atlanta in the summertime, and one of those threats is air quality. And one of the impacts that climate change will have on air quality, which is one of the principal ways, in the United States at least, in which climate change will affect health, is through the greater occurrence of high ozone days as a result of higher temperatures. So ozone is a pollutant that is created through a photochemical interaction between sunlight, smog precursors, and temperatures. So temperature is important, sunlight's important, and when you get hot days, and increasingly frequent hot days, the number of ozone exceedance episodes increases. So this is the curve showing temperature. There's no curve, but just the scatter plot of that. And we see New York City as well. We expect the number of ozone days, high ozone days, to be quite significant in the future. And this is actually a modeling study looking just 5 years from now in the 2020s. The reaction, this is Long Island, of the projected change in pediatric ED visits for asthma as a result of a trigger from an ozone episode, just as a result of increased ozone exceedance days in the New York and the downwind counties, and up to a 10% increase for pediatric ED visits in the 2020s. So something like this wouldn't make the news. You wouldn't probably know it, but if you dig through the data and you look at this insidious, low-level, persistent impact, especially on the most vulnerable children, the elderly. Children have higher respiratory rates than us. They're much more vulnerable to air quality impacts, as are the elderly. We've got to pay attention to this and start monitoring and evaluating this and assessing how this will impact these vulnerable communities. Another way in which air quality is impacted by climate change is through, again, a small, largely unnoticeable but very consequential impact, is through the increase in aeroallergens. So this is ragweed here, and a colleague of mine at USDA, Lou Ziska, did a study where he said, and this was mentioned last night by Marcia, carbon fertilization. We'll come to this a number of times, but excess CO2 in the air, and in this case, excess CO2 in urban areas, because urban areas have a much higher amount of mobile source emissions, cars and whatnot, meaning that the local amount of CO2 in urban areas is higher than the surrounding rural areas, upwards of 500, 550 parts per million versus the global background 400. That is important for plants, and ragweed is especially impacted. And what Lou did was he took a transept across Baltimore on the same latitudinal gradient, and he got the same plant, the same soil, identical plots, and he planted one in a rural plot, suburban, and urban, and he measured the CO2, so the suburban and rural were about the same, 400, that's kind of global background, and the urban was around 500. Well, what it did to that urban plot was it increased the amount of pollen that particular plant produced from 2,200 or 2,300 grains per cubic meter of air all the way to 12,100 grains per cubic meter of air. So that's remarkable. And not only is the output of plants greater under CO2 fertilization, but the length of the pollen season is increasing as well. So we've taken data in my shop at CDC of allergy clinics, and we've speciated them into, I don't have a slide on it, but we've shown that for Atlanta over the last 9 years, that the trend for all pollinating species or pollen allergenic species, except for maple for some reason, we can't figure that out. All of the others have gone up dramatically in Atlanta, in my neighborhood. So it's a big problem. And we're also seeing a shift in the length of these pollen seasons. This is another study you did showing that, again, you saw the warming was much more pronounced up north. And the length of the ragweed pollen season in Manitoba is now 26 days greater than it used to be, and 24 days, where's that, North Dakota, and all the way down. So the ragweed pollen seasons are lengthening, and this is associated not only with temperature and growing season changes, but also with carbon fertilization. And you might say, okay, big deal. Who cares about ragweed? Well, we should, because annual costs for rhinitis are around 11.2 billion, and annual economic costs are over 5 billion. This is not something to sneeze at. And so, yeah. So as pollen counts increase, we can expect this, again, this low-grade, insidious, persistent threat that is going to degrade air quality, and we've got to do something about it. Another impact of the climate change has on air quality, especially those communities downwind, are wildfires. Since 1970, the wildfire season has increased by over 2.5 months, and the duration of fires has increased 5-fold. Now, of course, wildfires aren't caused by climate change, but the sparking events can be with convective activity. And certainly forest management practices are principal among these causes. But warmer temperatures and much more lightning strikes as a result will certainly lead to this, and we're seeing a change in wildfire season. And again, big deal, yeah, for those downwind, we see an increase, and this is 10 micrograms per cubic meter, which is a measure of PM10, which is particulate matter greater than 10 nanometers. Larger particles in the air, increases non-accidental mortality by 1% in some studies. And it all depends on what you're burning. So in Australia, the brush fires, they saw during the downwind communities from Australian brush fires that overall mortality rose 5%. That's not inconsequential. Would you lose 5% of your, or to lose 5% more people? And hospital admissions for respiratory and respiratory illness increases as well. So we do have observed in long distance impacts from wildfires on downwind communities. Again, a small but important threat that we need to take into consideration. Okay, now switching from dry areas and drought and wildfires to water, we notice that as the atmosphere increases in temperature, we can add a lot more water vapor to the air, increasing the turnover of the water cycle, and increases in heavy downpours is really the consequence, going from drizzling rains to heavy downpour events. And this is the observed record in the United States. When we look at observed changes in heavy rainfall events, this is rainfall above the 99th percentile for an area, inundation events. We notice that it has been a significant trend, again varying regionally, but an important trend nonetheless. If we look at the occurrence of heavy rainfall events and waterborne disease outbreaks, we notice there's a pretty good relationship as well. Of all the waterborne disease outbreaks that CDC has been able to identify, 2/3 of them were preceded by rainfall above the 80th percentile, and half of them were preceded by rainfall above the 95th percentile. Meaning, when we have these large flushing events, you mobilize pathogens in the environment, and you send them into areas that have to handle and manage them, and sometimes we're not good at doing that. This is actually the largest waterborne disease outbreak in U.S. history, 1993 in Milwaukee, the Cryptosporidium, 400,000 cases and 54 deaths. Now this was, again, preceded by the heaviest rainfall in 50 years, but it's an example of how our infrastructure of the 20th century is going to be overwhelmed by the weather of the 21st century, especially with regards to managing these extreme events. So what happened in Milwaukee was a large flushing event leading to a discharge into Lake Michigan. The intake for the system was sufficiently placed far enough away from the intake, or the discharge in the intake, based upon other average discharges. It wouldn't affect it. But this discharge was so large that it was taken into the uptake of the system. Crypto is not chlorine sensitive, so it got into the system and was, again, resulted in all that illness and lost productivity, et cetera. So we have to re-engineer our systems to understand that the new regime is going to be much more challenging than the old, especially with waterborne disease outbreaks. So again, to our third and final key threat from climate change is that large-scale changes in the Earth's ecology are going to result in surprises. Large-scale ecological perturbations facilitate disease emergence or redistribution. So things are going to pop up in areas where we never saw them before or move to different areas. And we're seeing that in a number of places. I'm from Florida, so I'd like to show this about harmful algal blooms. Before, they had not been that frequent, red tides, and had been seen as a kind of a nuisance event for tourism and fishing and not great for business. But we're now realizing that this classic red tide, Carina brevis, actually, when it gets, the cells get beat up in the surf zone, aerosolize a toxin called brevetoxin, leading to respiratory distress. So we've measured lung function in lifeguards during these events, and they go down significantly. And if we're telling old folks to go on walks on the beach, we ought to be cognizant of this threat to their respiratory health. Other threats, and these are all driven by increased runoff of nutrients from farms and whatnot as a result of heavy rainfall, but also for increased water temperatures. But we're seeing some surprises. This is the distribution. These dots here are the new distribution of a formerly tropical harmful algal bloom, harmful algae, called Cylindrospermopsis, which is also a potent liver toxin. And these are new challenges to water quality, especially drinking water quality, that are not currently monitored or regulated under safe water regulations, EPA safe water. So we have to understand emerging threats. And if you recall last year with the microcystin bloom in Lake Erie, these types of threats are going to become increasingly common. This is a study I worked on in the Gulf of Mexico. Anybody heard of ciguatera fish poisoning? It's the most common form of seafood intoxication worldwide. It's a GI illness that turns into a neurotoxin. It's debilitating. And it's caused by consuming fish that have eaten a toxic algae that are early colonizers of disturbed reefs. So after a coral bleaching event from warm temperature or being ground up in a hurricane, they proliferate in these areas. They're early colonists and can intoxicate fish through bioaccumulation up the chain. So little fish eaten by the bigger fish. So you get the barracuda and the amberjack and the grouper accumulate this toxin. They appear normal, they behave normal, there's nothing wrong with them. You can't test them for ciguatoxin effectively. You can, but it's very expensive, not pragmatic, and they taste normal, but then you get sick and you get very sick. So we suspend, cases in the United States are increasing, but we have no way of knowing where it's coming from because it's hard to track where fish were caught, or even what type of species it is, to tell you the truth. And what we decided to do was to figure out if this formerly tropical threat to marine ecosystems was moving further north, and we had reason to believe so because the Gulf of Mexico now has lots of coral-like structures. This is an oil rig platform. There's more than 4,000 artificial reefs or oil rig platforms in the Gulf Coast of Mexico, on the Gulf of Mexico, which being muddy bottom doesn't have very much hard substrate for coral to form on. And so because of all this anthropogenic habitat and because we've now warmed up the water in the Gulf of Mexico, we figured, by gosh, ciguatera ought to be there. But we can't really do surveillance for it in emergency departments because physicians there have never seen it before. They would not know a case of ciguatera if it hit them on the head. And they would just code it as foodborne illness of unknown etiology and take care. So we decided to go to fishermen, and we handed out these magnets and beer huggies and said, if you ever get sick from this, call us up. And we collected fish samples from, they have GPS coordinates of their fishing spots, and they had a clinically compatible illness and a hot fish. We sent it off to FDA, and we confirmed that this ciguatera fish poisoning is now found off the Gulf of Texas. Now, it's established in areas that had never been established before. We also got a case in South Carolina showing the northward spread of this, this seafood toxin and threat to this. Now, another one that is spreading and is a bit more consequential is Lyme disease. Lyme is sensitive to a number of factors related to the ecology of the tick, the behavior of people that actually want to go out and be near the ticks, and preferences of where we put our houses and things like gardening and whatnot. So we know that the spread of Lyme disease has multiple factors. Climate is one of them because it can affect the tick ecology. So using this, some researchers out of Yale decided to model the potential. This is 2002, I think, 2003. And they said, let's model, given what we know about Lyme ecology and people, and see where it will go into the future. So this is 2012, 2020, 2050, and 2080. So keep that image in mind. This could be our newest export to Canada. And then now let's look at observed data. This is CDC data, case distribution data of where a dot for each county in which Lyme disease is found. This is 1996. This is 2011. And the new map for 2014 is just even more dense and even more further north. And so this is obviously shifting in its geography. We're finding ticks further north than we've ever had before, and yes, they do have Lyme disease in Canada, and are trying to get ahead of this as a threat that is responsive to climate changes. And why is it responsive? Well, if you have milder winters, more of the ticks can survive over winter. So you start with a higher density of ticks or number of ticks. If you lengthen, you hear me? Then their reproductive cycle, they can actually get more reproductive cycles in a year. The tick behavior itself, the nymphal ticks that are actually have to take a blood meal on humans, are more active when it's warmer, and they're a little more aggressive in questing or finding a host to take a blood meal on. So there's a number of behavioral factors, and also people are out there more in nature when the seasons are longer. So there's a number of factors interacting with this. So we expect things and new threats to emerge, and some of them are going to be quite unpredictable. We talked last night a little bit about food security and climate change, and initially, there's a lot of attention being paid to this. This is a very important field, looking at how climate change will affect crop yields and crop success, et cetera. And early on, there was some rosy pictures about how CO2 fertilization might affect agricultural productivity. The Russians were looking like, this is great. Actually went to a meeting with my Russian counterpart, and he says, I have such a hard time getting traction on this issue because the general mood in Russia is pretty positive about climate change. They're like, yeah, bring it on, because agricultural productivity and less winters. But recently there's been some pretty disturbing news about the impact of CO2 fertilization on crops itself, not just the yields, which might go up. It might go down if you have some vulnerable systems that are like rain-fed agriculture or whatnot. But just looking at the protein concentration of crops, this is one of the many important things about crops. And this is a meta-analysis which takes a number of different studies and looks at the results of them, shown that these crops, which by and large feed the world, have shown under elevated CO2 a reduction across the board in all studies, not even crossing into the positive impact of the crude protein in these crops. So if we are engaging in a world of 500, 600, 700 parts per million CO2, what kind of crops are we going to be growing? How are we going to be able to handle this? And this isn't just in those, or just protein. It's a decrease in zinc and iron in C3 grasses, iron concentration in maize, protein content, and so micronutrients and macronutrients are all going to be important challenges that are going to have to be faced, because at the base of public health, at the base of all health is nutrition. And so this is a emergent threat that we have been talking about for some time. Another emerging threat that we have to get our heads around is mental health issues, and we do not a very good job of identifying and treating mental health conditions, but these certainly are going to increase into the future. We know that following disasters, one of the most impactful and costly and persistent health problem from any disaster is the mental health consequences of those disasters. We lost 2,000 or so people in Katrina, but there are still many, many thousands suffering from the health consequences, the mental health consequences of being dislocated from your community. You're losing your job, losing your family perhaps, and suffering through that. So we have to understand that there are definite larger impacts than immediate morbidity and mortality from hurricanes, let's say, or large-scale disasters that need to be accommodated. But there's also another insidious threat to mental health, just living in a world where we have this potential for severe global change. And I call this the anticipatory mental health a problem, where we're living in a world that's kind of gloomy. And I actually get invited to participate in studies. Climate scientists, we want to know how, maybe Naomi, you've been invited to the psychological implications of working in climate change. We want to know about how I deal with it. And I've participated in a few of them. And I've always thought that the best way to tackle a problem is actually work in it. So I kind of feel better about working in climate change. I'd probably be more bummed out if I didn't. But there's an interesting one about kids and how they perceive this problem. Climate, and this is BBC, not a scientific study, but still, the results of this study showed that 3/4 of 11 to 14-year-olds worry about climate change, compared to 41% who are worried about going out with someone. That's pretty tough competition. I mean, what's on a 14-year-old's mind? And if it's climate change, we've got to address that. We've got to put that up front as saying, wow, you've got to think about this. And this brings to mind a concept that's emerging in the mental health literature, solastalgia, where this says, this past summer I got deeply depressed about our planet, as if I didn't have enough problems of my own. And this is emerging as an identified mental health condition, where people living in degraded environments or marginal environments or not pretty places, actually it affects their mental health. And consequently, that's why we like to go hiking and go climb mountains, because it makes us feel better. But this is certainly one of those consequences of climate change that we might have to think about. And it's not just linked to degraded natural environment. The natural environment is tied to a lot of cultural importance. I'm an anthropologist, so I pay attention to this, and we work up in Alaska. And I asked the folks, well, okay, you live on this bit of land in the middle of the Chukchi Sea. Let's move you in a little bit. It's a little bit more reasonable to live over there. I said, this is where our ancestors are. This is where we are. This is our identities tied to this place. You don't just take us and put us over there. We have to bring our ancestors with us. And a big part of the problem of relocating these communities is relocating the graveyards. And they're losing them to sea as the land-fast ice isn't forming early enough to protect them from storms, winter storms, and the land is literally crumbling into the sea. And I'll show you other pictures in a minute. So, to bum you out further, the impacts of climate change, CO2 levels, temperatures, weather extremes, and rising sea levels all impact a wide variety of exposures, from air quality to severe weather to changes in vector ecology, which impact a wide variety of health outcomes. This is not a trivial task to address. None of these are things we haven't seen before in public health. Where we see them is the important part, and what we can do about them is even more important. So let's go to what we need to do, the path forward. What is the way we can start addressing this? And the first, I believe, is that we need to reframe the climate change dialogue away from climate change being about polar bears and plants and penguins, and really about people. And we need to focus on climate change as an environmental issue. And the way to do that is to identify ways in which people can benefit from environmental action as well as the environment. We're not tackling climate change just for the environment's sake. We're actually doing it for ourselves. So this is my family in Atlanta. Come on. This is how we look at Atlanta. And though this is something that hasn't been seen for a long time, as kids walk into school. And we have decided that we need to put schools on the edge of town. We need to get these big buses and take them far away from our houses and send them to the hinterlands for school. And we lose great opportunities for tackling a number of things related to climate change. And the first is that by taking kids off the sidewalks walking to school, by getting kids to walk to school, by putting schools in neighborhoods, we actually can reduce CO2 emissions by getting buses and cars and whatnot and the drop-off lines off the roads. So that's a simple way we can tackle climate change, with a simple act of walking to school. Consequently, we increase physical activity in kids. The #1 challenge to children nowadays is obesity. And it's a crippling problem for youth that we know part of the solution for it. A third thing is that by getting cars off the road, we improve air quality, decrease emissions. If you take measurements, I've been to the Safe Routes to Schools meetings, and air quality around drop-off lines or the school bus drop-off is awful. You do not want to be there. You definitely want to drop your kid off down the corner and say, walk in with your hands over your mask, or mask over your head. Getting people out of their cars if they're behind glass and steel actually allows people to talk to each other. And you can actually see your neighbors and get to know who people are by actually talking with them. What we know that the number one predictive factor of how well a community will respond to a natural disaster is the density of the social networks. That how many people know each other and the quality of those relationships can predict how well a community will respond to a perturbation. It makes sense that if you know Mrs. Jones down the street can't walk and she needs help, you'll go help her. If you don't know who she is or what they might need, you can't help. So we need to increase the density of social networks and the interdependency of people in communities. By getting people out of their cars, they can actually talk to their neighbors and get to know their patterns and their rhythms, and if a person can't walk very well because they're coming to the curb to get their newspaper. We also have other benefits. Exercise decreases depression, injuries from motor vehicle accidents, and number one cause of morbidity for children 3 to 33, or that age group, as well as so on and so on, and by the way. So there's a lot of things that can be benefited by simple policies that tackle not just climate change, or maybe don't even tackle climate change, but have this insidious purpose of tackling climate change, but focus it on a human welfare or a health issue. That's important to have in the first place. And there's numbers of them that we can target to be subversive climate champions without saying the word climate. Second path that we need to focus on is targeting those most vulnerable, because they are more vulnerable and for particular reasons. This is my colleague Kirk Smith at UC Berkeley. His comment is that in a world of climate change, the rich will find their world to be more expensive, inconvenient, uncomfortable, disrupted, and colorless. In general, more unpleasant and unpredictable. Perhaps greatly so. The poor will die. This is true. If we look at the cause of climate change in a spatial sense, if you've not seen this website, worldmapper.org, please check it out. But this is the representation of the relative contribution to this variable, carbon emissions, on the basis of country. So we're overrepresented on this map, so is Europe. But if we look at, and we are responsible for 1/4 of the world's gases that cause global warming, we know that. But if we look at the consequence of this impact, climate-related mortality, we shrink to nothing. And this is borne by the global south, those who are less responsible for the problem, but are going to feel this impacts more because of the vulnerability of their communities to many of these health impacts. And this isn't just limited to the global south. This is in our communities as well. These are pictures from Katrina, and the resilience of these communities is, by virtue of their position in our social hierarchy, diminished, because low-income people can't rebound from these types of stresses as well as other folks. I have family in New Orleans. The day after Katrina, they had their kids in private school in Houston. No problem. When their house was fixed by the insurance company, they moved back in and they went back to business. Didn't even miss a TV show. So, and these folks are still struggling from the repercussions of this. So we have to focus on those most vulnerable in our communities. So the third and final path, I think it's the final, is to expand the coping range. We know that climate change, we're committed to climate change impacts. No matter if we stopped emissions today, it's still going to incur some warming. And we need to increase the range in which our communities can be protected from these impacts. And that's my job at CDC. We do this in a number of ways by identifying threats and trying to identify pathways into this risk equation. We've written on it. We have adopted a philosophy of adaptive management for our programs. And we look at the risk equation. We say, well, what can we do? We can reduce the hazard probability. That's not likely to happen. We don't really have much leverage at CDC to change emissions, to change the probability these hazards are going to occur. But we can reduce the hazard exposure, getting people out of harm's way, finding ways of protecting people from these exposures, or addressing the underlying vulnerability to those exposures, comorbidities, chronic health conditions, et cetera, and develop ways of protecting health and reducing vulnerability. So this is what we do at CDC. We do modeling, we look at adaptation in action, and we also do a number of things. We have what our main goal at CDC is to help states and cities. We focus initially domestically in the United States on state health departments. We provide scientific guidance to these health departments. What is climate change? What are your options for assessing the impacts in your community? How might you manage this risk into the future? The sad part of the story is that my small program at CDC is the only shop in town in the U.S., largely in the world, to address the health challenges of climate change. It's largely an unaddressed issue. we're working on making it more of an important issue. We have what we call the Climate Ready States and Cities Initiative, where we fund 18 health departments, 16 states and 2 cities, to do climate change adaptation over multi-year grants. Here are the communities we work in. Sorry, Missouri, we didn't get a grant application from you. But we work in these communities that represent all kinds of different challenges, from Florida and hurricanes and harmful algae to Oregon with wildfires, heat waves, and a number of other issues, Midwest with water quality issues, et cetera. And we work with them to assess the projected changes in climate, which will vary significantly between these places, what their new emergent threats will be, and how they can manage it. We do this through an adaptation planning framework or a model that we've developed called BRACE, stands for Building Resilience Against Climate Effects. That's an evidence-based, empirical way of assessing your climate impacts and vulnerabilities, projecting into the future what your disease profile might look like. And in some cases, like Oregon, it introduces new challenges. They identified heat waves as an emerging threat. They never had a heat wave in Portland before. They weren't really ready for it. But lo and behold, last year they had 2 heat waves, and they were ready for it. And they said, wow, we took a look at the future. We discovered heat waves. We found out all we can do about heat waves. We got some things in place, and we had 2 heat waves last year and didn't have a problem with it. We assess these interventions that can happen, that can be put in place to manage these threats, and we implement this in a plan. We implement it and we evaluate it. So this is how we use an evidence-based empirical approach to adapting to climate change. We also provide guidance on how to do this through technical assistance. We develop guides on how do you use a climate model and a climate projection for a public health department. They don't know how to use this type of information, so we have to translate the climate science for them, put it into tools that'll help, all the way from assessing vulnerability and projecting disease burden. If you want to learn more about it, the activities and what adaptation really means, we have partnered with the American Public Health Association to develop this document called Adaptation in Action. It has a number of what they do and what the threats are and how these states are adapting to it, whether it's ticks in New York or a waterborne disease in Wisconsin. But we're also pioneering new science. We understand that the traditional ways of assessing risk and managing risk kind of need to be rethought, and that's where my role as an anthropologist comes in. And I say, well, you know, there's a lot of things that communities can actually tell us rather than us telling communities. So we've developed a model for citizen science or community-based participatory research where we actually go into communities and say, how is climate change affecting your health? And the most obvious place is Alaska. This is an example of coastal erosion. This is ice or permafrost here. You can see little bands of it. And they're having a severe problem with land changes because of permafrost thaw. It's just too warm that the permafrost is melting or thawing underneath the layer of soil and it's slumping in. So we, over the last 5 years, have been collecting evidence from these communities, and we found some really interesting things. This is the bottom of a food cellar, which is a very important way of storing food in Arctic communities, a lot of marine mammals and whatnot. And it's important for food processing techniques too. They ferment whale blubber. It's critically important that when you start the whaling season, you have to eat some of this fermented whale blubber, otherwise your hunting season will be terrible. It's terrible, actually, whale blubber is. And they store it underground in these food cellars that are increasingly warming and becoming dangerous places to put food. There's actually water around here if you can't see it. But these food cellars are becoming point sources of foodborne outbreaks in these communities. And we need to develop ways of better insulating them, finding better places for them, and getting ahead of this threat, because this is unique to their cultural experience. I mentioned erosion of the landscape. This is in interior northern Alaska. This is north of the Arctic Circle, a community called Noatak. And this community had been serviced by the Noatak River for many years. They brought barges in with oil to run the generators. This is in the middle of nowhere. And food and all their supplies came in on barges. Well, because of this erosion of the landscape around the rivers, and if you stood, no, I was standing right here, you could stand like you were watching an iceberg calf off a glacier. You know, you sit there, wait, and then it clumps in, right? Well, this riverbank of the Noatak River does just that with soil. Soil is dropping, boom, boom, all over the place. It's right in front of you. The river is eroding. Well, now this river is unnavigable because of all the sedimentation in the river, which means they have to fly in everything. all their food, everything else. It changes access to health care, changes many parameters of their world because of this impact that we never would have understood unless we had actually talked to people, which is a unique strategy. So towards that, I want to end by the plea that if we think about climate change and we want to move action on climate change, that we really need to reframe our dialogue away from the polar bears and penguins and plants to really to those most vulnerable, in this case, kids. But I think this will help personalize this as not an issue that's distant in space and distant in time, but here in our communities. So to conclude, the summary is that we are already seeing these impacts of climate change in our communities, in our own communities, not just distant. We need to frame it as a human welfare issue and a public health issue, but hopefully early action and evidence-based approaches can help to protect the public's health from this threat. So thank you so much for your time.
We'll take a few questions. Raise your hand if you have one.
Hi. So, in what way are you coordinating with FEMA and you know, I guess the National Guard and?
We coordinate through. We have a federal coordinating body of climate change work. It's called the U.S. Global Change Research Program. And that consists of multiple groups of different topics, from Earth observations and satellites to the carbon cycle, and I chair a group on health. And in that group, we bring in parts of the federal government. So we have FEMA, we have Homeland Security, Department of Defense, NIH, of course, NOAA, Weather Service, about 30-some different groups. And we work with each other to give each other situational awareness of what we're doing, leverage their resources, and help work together. So one example, FEMA is participating in a number of cases right now. We're working on a plan to ramp up this summer on extreme heat preparedness following El Nino. So that's one specific example. But we do other things like coordinate the thresholds at which alerts will be given by the National Weather Service. So we do the science and say, you know, you issue a heat alert over here, what's that based upon? And they say, well, it's 95 degrees. We say, why? They say, well, we don't know why. It's 95 degrees. Actually, the heat threshold for Miami is lower than that of Portland, Maine, and so, which is like 100 degrees. So we said, wait, okay, well, let's work with you. We'll take the health data, we'll do the analysis of thresholds, temperature and morbidity, or even mortality, and we'll develop ways of assessing these thresholds more accurately. And so that's one project we're doing right now with the Weather Service. But we try, and this is very new, so this work group didn't exist when I started representing CDC at this program, and I screamed and hollered for it, and they finally said, okay, you can have your work group. And it's been a tremendous success in coordinating lots of different interagency activities and I was mentioning to somebody earlier, they were saying, what are you doing here? You're the health guy, what are you doing in a climate change group? And I said, well, because we're concerned about climate change too. And then once the light bulbs went off, they said, wait a second, you mean our products, our satellites that measure land surface temperature and all of our esoteric science actually has a societal benefit? Tell me more. And they are very excited to be able to apply their products to our mission, which supports their mission. So there's, once we got in the door and they realized, they said, wait, let me make you a place at the table and welcome. It's very good to see that has been received so well.
Up here. Thank you so much for a great presentation. And a couple of things I was wondering. You're talking about the burden of climate change falls on the poor and the vulnerable. So, and I loved your examples of citizen science. Are there other examples you have of how those that are most vulnerable are involved in kind of creating the action plans to deal with some of these issues? And I'm curious because I worked with a group called Pathways to Resilience, and they were asking so many of the same questions.
That's a great question. We come at it both ways. We use empirical methods to say where the most vulnerable locations are. So we'll say, let's look at an urban area, and we know that within an urban area, let's say, I've worked in Philadelphia, that the exposure to temperatures across the landscape changes a lot from a well-vegetated, wealthy suburban area might rise 2 or 3 degrees versus as a result of the urban heat island versus the background temperature. A poor area that has no landscaping, no tree cover, no canopy might go up 12, 14 degrees. And so there are hotspots. And those hotspots typically correspond to areas that don't have a lot of vegetation, access to parks, et cetera, and they're typically poor areas, and that's pretty well established. And so we say, let's say a city's going to do a tree planting campaign. This is one of the reasons we worked with the city of Austin. They were going to plant, I don't know, 500,000 trees. We say, wait a second, don't just plant 500,000 trees. Figure out where those trees are needed most, which areas you can impact the temperature profile the best, and make sure you plant trees that aren't going to produce bad aeroalgae at the same time. That might help. Now, we fund states who then work with their communities to develop the appropriate interventions. And that's how that vulnerability is assessed there. So say you have communities that have low access to public transportation. Instead of just putting a cooling shelter in an area, you might say, it's also important for us to provide transportation to that cooling shelter, or allow people to bring their pets to the cooling shelter because they don't feel comfortable leaving them at home. So those local strategies for effective interventions, getting at the most vulnerable, are done by our partners at the city and county health departments. And so, and it varies greatly by area. So we provide the tools, and then they assess that and bring in the locals. Hope that helps.
I have a question about baseball games. Basically, they have rainouts in baseball games, but I don't know of any game that's been called because of heat. And I wonder if the CDC would be working with the baseball and sports in general that they just seem to go on regardless. And I look at not just the players and what that effect is on them, but also the participants, the spectators who are sitting through like really hot weather. My theory is that they may be doing stress to their body that doesn't show up until later, and I'm wondering if there's any studies that show that this is not a good idea, and that possibly baseball should have something like a too hot day and call off the game because of that.
Yeah, again, great question. We're a non-regulatory agency, so we won't make any pronouncements of that sort. But I'm a tennis player. I grew up playing tennis, and tennis does have a heat rule, that if it gets too hot, they cancel certain events, which I think is brilliant, because we lose student athletes every year to extreme heat. And we lost a kid in 2004 in Rockdale County outside of Atlanta to heat. This is after sitting on the couch all summer, then going to 2-a-days in August with pads on, and they're overwhelmed. And we lose kids all the time, every year, to heat illness. So what we decided to do was understand the context in which these kids are dying. There's independent pressure from themselves to perform and to stay involved in the game. And coaches or athletic trainers or other people supervising might be unable to identify that this kid's at risk. So we developed a course, an online course that's accredited by CDC University, and you can take it for CEU credits or whatever, because we worked with the coach community because they need those accreditation or continuing education courses. And the course is called Recognition and Prevention of Heat-Related Illness in Student Athletes. And we did some research, and the best way is a surround approach where you don't educate the person at risk necessarily, you educate those people that are around them to be able to identify that kid is not looking good. We need to pull him off, coach, and empower kids to talk to their coach or the coach to do that. So our policy has been to give people the tools to make those decisions on their own. We were asked by the Georgia High School Association about heat threshold rules, and we realized that if we set a specific threshold, that there'd be a competitive disadvantage for some areas, because South Georgia, which is on the coastal plain, would exceed that threshold far more often than the northern, in the Piedmont schools, and there was a big outcry about that, and we said, well, you guys need to manage this on a state-by-state and jurisdictional basis, but here's the tools that you would be able to assess that by, and give them the information and let them make the rules. Again, we don't set those rules, but we give them the information to make that decision as a science agency. And exertional heat stress is a big important issue, and the fans as well. I'm glad tennis has that rule for major events, for the heat rule. I think other sports should adopt that as well.
This was a excellent talk, and I just wonder if this information is available maybe online, or if you, I see it's being recorded, if there's a place where we can access it.
Oh, you bet. I'm a public servant, so all of this is in public domain. So you're welcome to my slides. And if they post it, you're welcome to download them.
So just so everyone knows, all of the talks are being recorded. They will be posted on our YouTube channel, and we'll post the link on the symposium website in a month or so. When they come available, we'll send out an email to our mailing list, and we'll put it on Facebook and Twitter, so you should be able to find out. We have another question right
And
here.
if you want, there's my email.
Thank you so much for really presenting the big picture, you know, and all the different aspects that are impacted. Along with the other talks in the symposium, really our Missouri state government needs to hear, you know, what all the issues are so that they could better understand what they need to be addressing in the capital rather than the issues that they think are important. My my question, I think you probably touched on this, but among other infrastructure issues, weatherization is one that I'm thinking maybe, you know, serves the dual purpose of reducing greenhouse gas emissions and would be protective for people, vulnerable people. Is that, am I thinking right on that?
Oh, no, absolutely. Weatherization is a great strategy. It's, I think we have to get the data on how cost effective it is, but if you, you know, for example, ED visit for a heat stroke runs around $8,000 to $10,000. New York City realized that and said, well, we should just hand out air conditioners. It'd be cheaper. And they are. And it's like, well, that's not a great strategy in the long term, but it's certainly cost effective in the short term. There's a program called LIHEAP, Low Income Energy Assistance or Heating and Energy Assistance Program, a very, very big government program that provides support for people in heating bills, right? We're trying to get them to consider cooling support as well, because people won't turn their air conditioners on in the summer, and it can be deadly. And there's not this perception that that's, but that's not even a good low carbon solution either. Weatherization is, because it not only protects them from these exposures, but reduces their vulnerability. Remember, I had that risk equation: reduce the hazard exposure, reduce the vulnerability to that hazard. Well, if you reduce the hazard exposure by making the house more comfortable and weatherized, you also reduce their vulnerability by reducing their costs in doing that, and keeping them from having more adaptive capacity, which is financial resources to have other types of health protection stuff. So weatherization is an excellent one. We hope to provide the evidence to support those types of policies. And that is one of those. I have a scientist on staff now that came to me about 2 weeks ago, and she wants to do a pretty fancy study modeling different types of neighborhoods and different types of housing structure and its response to heat wave to provide the data for that. But we are looking at weatherization as a strategy, and our communities are too.
I'll let one more question from Bill.
Comment and a question, which will be a segue into the next talk. Okay. I just want to remind everyone that Missouri is one of the states that has filed suit against the Environmental Protection Agency to block the Clean Power Plan, claiming that implementation of the Clean Power Plan is going to be too expensive. But the question is, I would appreciate you just giving us some comments about your experience and others' experience in your program testifying to Congress. I know you can't lobby Congress, but if you would reflect on your experiences, because I think that will give us a good introduction to the next talk by Dr. Orestes.
The Clean Power Plan is one of my favorite things ever, because it's a response to a court order that said you have to regulate CO2 because it's a pollutant. And it's called the endangerment finding. And the reason it's a pollutant is because of the evidence that we've assembled. And if anybody's read the Clean Power Plan, in the preamble, in the first page, our work is cited. And so when I first came out, I went to my staff and I said, guys, look at this. Your work is in the first page of this super important regulation. What we do matters. And everybody was just so happy. And it's like really impactful that the health basis of this threat is really why this plan is going into place. I think if you looked at the cost of implementing the plan versus the cost of not implementing it, and the real costs, people might change their mind. We're testifying to Congress. I've not testified directly to Congress, but we respond to congressional inquiries all the time. We provide the evidence. I don't know where to go with that.
I'm looking for a segue into Dr. Arez's talk, where I think she's going to talk about the influences that Congress, the backdoor influences upon Congress. But I'm just wondering, what invitations have you had to testify to Congress about the findings that you described today? Because it seems to me that these are so important that Congress really needs to understand.
Yeah, very few. No invitations as of late. We do congressional briefings sponsored by American Meteorological Society or American Public Health Association and brief congressional staff on this issue. I know that this is noticed, the congressional, the loudest voice of the Congress is its budget. And that's really, from our perspective, what matters. And the budget this year, and I was terribly proud of this as well, the budget comes from the President first, and then it comes from the House and Senate. And when it came from the House and Senate this year, it had our program, which is a separate line in the budget, which is kind of unusual that we stick out like that, but it's been that way. And it had our program eliminated. And not only eliminated, but it also had a provision in there that says prohibits CDC from engaging in any BRACE-related activity. And BRACE is our framework for planning that is so subversive. And that, I couldn't have been prouder. I really was. I brought this to my staff and said, look at this. People are noticing this is working, that we're providing the evidence base for these impacts. And this is the biggest compliment we could ever get. By the way, half of you are going to lose your jobs tomorrow. Yeah. No, we actually, so our budget actually came in, and to our surprise, it was increased by about 20%. Yeah, so we didn't send anybody home, but that's how Congress speaks loudest, or the horse trading that goes on behind the scenes. So we're still alive. We still do. We're actually expanding our work this next year away from, including the states and cities. We're now opening up a new funding opportunity for tribal governments and territorial governments, so climate-ready tribes and territories. So we're proud of that and hope to just stay low.